Okay, so hello everyone. In this session, we are going to solve another problem from CSES problem set. This problem is called Hamiltonian flights, and this comes under the graph algorithm section of the problem set. Okay, so the problem statement is quite straightforward. You have n cities and m flight connections between them. Means you have n nodes and m directed edges. All the flight connections are one-way flights, so you can assume all the flight connections in the form of directed edge. So there are n nodes and m directed edge in the graph. You have to travel from city A to city B, and those A to B are 1 and n. So you have to travel from node number 1 to node number n, such that you visit each city exactly once. Such that you visit every node exactly once. So you need to find how many possible routes are there. Okay, and you have to print the number of routes modulo 189 plus 7. Okay, so first look at the sample example that they have been provided. Okay, so you have n equal to 4. It means 4 nodes 1, 2, 3 and 4. You have n equal to 6, m equal to 6. It means you have 6 directed edge. First one is from 1 to 2, second is from 1 to 3, then 2 to 3, 3 to 2, then 3 to 4, and and another one is from 2 to 4. Yeah, so how many you have to travel from 1 to 4 such that you cover every city exactly once. So how many ways are there? First one is you go from 1 to 2, then you go from 2 to 3, then you go from 3 to 4. So 1 to 2, 2 to 3 and 3 to 4, this is your first valid way. Second valid way is, and look, this is not a valid way. You say 1 to 2 and then you go to 2, then you go 2 to 4. You say I have started from 1, I have ended at 4, but this is not a valid way because you have left city number 3. So you have to visit every city exactly once. So what can be second valid path? You go from 1 to 2, then you go from 2 to 3, then you again go from 3 to 2, then you visit city 4 via 2. So 1 to 2, 2 to 3, 3 to 2, and again 2 to 4. This is the second valid path. So you have to find all the valid paths. Okay. I hope you may be familiar with the concept of DP with bitmasking. If you are not, then no problem. I will try to explain a little bit of DP with bitmasking. Okay. So first of all, think in terms of think of another problem. Let's say you were not required to travel every city. In that case, you have to just give me the answer of how many paths are there from city 1 to city n. In that case, definitely this path will be considered as a valid path because there are no constraint of visiting every city exactly once. Okay. Okay, then what we will do, we will just say, okay, I don't know how many paths are there from city 1 to city n. I don't know. You just give me how many paths are there from C sorry how many paths are there from city 1 to city number 2, and how many paths are there from city number 2 to city number 3, sorry, city number 1 to 2 and city number 1 to 3. How many paths are there from city number 1 to 2 and how many paths are there from city number 1 to 3? I will add both the path and I will reach the city number 4. Reason being, let's say you have 10 paths from city number 1 to 2, then all those 10 paths will contribute to city number 4 because you can travel from city number 2 to 4 easily. Similarly, let's say you have 20 paths from city number 1 to 3, then all those 20 paths will lead you to city number 4 also because there is a directed edge from 3 to 4. Means you can reach city number 3 with 20 paths from 1, then you can reach city number 4 also with 20 paths via 3. And similarly, if you can reach via 10, you can reach city number 2 via 10 paths, then all those 10 paths will also go to city number 4 because 2 and 4 have a path together. Okay, so if we didn't have the constraint of visiting every city, then this question is pretty trivial. You have to just find out how many paths are there from city number 1 to all those cities which have a direct edge to the our destination city. Like here our destination city is 4, so 4 have a direct edge from 2 also, from 3 also. See, so you just find out the answer from you just find out the answer to 2 and answer to 3, add those answers and you will get your answer of 4. Okay, but in this problem this is not the case. You have to visit every city exactly once also. So because of this constraint, you have to maintain a set. You have to maintain a set of all the visited cities before going to the next city. Let's say you are going to city number 3. If you are going to city number 3, then you must have maintained a set of all the visited city. You have gone from 3. You have gone to 3 via which of the cities? Let's say you have directly gone to 3. Then your set contains just an element 1. You have gone from 1 to 3. Let's say you have gone to city number 3 via 1 and 2. You have followed this path 1 to 2, then 2 to 3. So you have visited 1 and 2 before going to city number 3. So you have to maintain a set of all the visited cities in your DP state. So your DP state will be of the form DP of current city that you are going to visit and DP of all the visited cities set. But you cannot store the visited cities set. Reason being, how many sets can be possible? If n equal to your constraint on n, you can see from the problem statement, n can go from as small as 2 to as large as 20. So if n equal to 20, how many sets are possible? You have 2 raised to power 20 sets are possible. And in each set, you are going to store 20 elements. In worst case, I mean not 20 elements, look like if this set contains only 1, 2, 3, then you are storing only 3 elements. Okay, so in general, let's say on an average, let's say you are storing 10 elements in each set. So your total memory of the DP state will become, or your total DP vector will become, you have 20 cities multiplied by 2 raised to power 20 sets, and in each set you are going to store 10 elements. This is not feasible neither in terms of time complexity, neither in terms of space complexity. Okay, so you cannot make this type of city in this type of DP state. So what can you do? You can do one thing. You can eliminate all the sets. Like, you are not required to store information in the form of a set. Like, you have to represent that you have visited, let's say you have n equal to 5, means you have five cities, and you have to show that you have visited city number 1, 2 and 3. So you just say you have visited city number 1, city number 2, city number 3, and you have not visited city number 4 and city number 5. So you can represent the whole thing in the form of a binary string instead of a set. But you will say, okay, but binary string will again take all the size. So to remove the binary string, we can make the binary string in the form of an integer using the concepts of bits. Like, this binary string represents a unique integer. This binary string represents a unique integer. 11100. 11100 represents what? 16 plus 8 plus 4, 24 and 4, 28. So instead of storing sets, or instead of storing binary string, you just store a integer. And now you can see that your DP state becomes DP of current city, comma, just an integer. We call it a mask, because this is a mask that will represent our set of visited city, that will represent set of visited cities. So now you can see that complexity has just come out to n into 2 raised to power n, and this is feasible. So let's proceed in this term. Now let's see, you are on a city number I. Let's say you are on city I, and your mask says, and okay, you are on city I and you want to find out how many ways are there, or how many paths are there to travel city I, to travel from city 1 to city I, such that your mask is represented by mask. What do I mean by this? I am defining the state of DP. What was our DP state? Our DP state was DP of, let's say, I comma mask. So what does it mean? What does it mean by saying DP of I comma mask? It means that how many ways are there to travel from city 1 to city I, such that your mask is represented by mask, or you can say your visited cities are represented by mask. It means, let's say I say DP of 3 comma DP of 3 comma 2. What does it mean? It means how many ways are there from city 1 to 3, such that you have visited this set, and 2 is represented by this set. So you have visited this set, and this set is just what you have visited, city number 2. You have just visited city number 2. How many ways are there from 1 to 3, such that you visit only city number 2? So you can say that there can't be any way. Like you have to visit from city number 1 to 3, and you are saying you just visit city number 0 and city number 2. So this is self-contradictory, no? You have to visit city number 3, but you are visiting just city number 2. So this can't be possible. If you have to visit city number I must be there in the mask. Like, how can you visit a city without visiting it? You may say, okay, I have not visited the city number 3 till now, but I will visit the city number 3 afterwards. But no, we are taking our DP state as that we have gone from city number 1 to city number I, and we have visited all those cities. Like, it is not, I am not taking mask as something I have visited before and now I will visit city number I. No, I have taken the mask in such a way that I have visited city number I. Now our mask represents which all the cities I have visited. Okay, like I have visited city number 3 I have visited, then after I am concerning about the mask. Like if I have visited city number 3, then our mask must contain city number 3. Okay, it is not before. Like if I am not saying that I am visiting city number 3 and already I have visited city number 1 and 2. No, this mask is I am representing this mask as I am visiting city number 3, and after visiting city number 3, what would our mask look like? So if I have visited city number 3, let's say city number 3 visited of 3 is true, that I have visited city number 3. After what I am after visiting the city number 3, what would our mask be? So the mask must contain city number 3 if I have visited city number 3. But if I am saying that I have visited city number 3 and mask in mask set, or in the mask that is used to represent the set, city number 3 is not present, then there is no way, there is zero way of actually doing this, because this is self-contradictory. You are visiting city number 3 and you have not, you are telling no, I have not visited city number 3, so this is not a valid way. Okay, let's say, so now I have I have to visit, let's say, city number I, and I have some mask. I have a mask, so I need to find the answer of city number I with a mask. So how can I do that? I will say, okay, let's go to our mask. Let's say our mask is something kind of this. So I have to find the answer for city number. I have to I have to find the answer. How many paths? How many paths from 1 to I, such that I visited mask cities, like all the cities that are represented by mask. I have visited those, and this mask city will always have the ith bit turned on, because I am visiting city number I am visiting. If city number I am visiting, then mask of I must be turned on. Okay, so I would say, look, I don't know how many paths are there from city number 1 to I, such that I visited mask cities. But one thing I am sure, I will only come to I from all the connected, all the directed edges to I, all the directed edges to I. I will only come to I from all the directed edges to I. Okay, one thing I am sure, and this is true. Like if there is no edge from 1 to 3, how can, if there is no edge from 1 to 3, how can I go to 3 via 1? No, how can I go to 1 via 3? This is not possible. So one thing I am sure, that I will go to I from all the directed edges to I. Okay, so I will ask my all the directed edges, like I will ask all my parents from where I have a directed edge. I will ask all my parents. Okay, I will ask all my parents, and if I have to make sure that my mask was something this, and let's say my I was this, then I will ask my parents and say, okay, you find out the answer from my parent and turn off my mask. Because why I am turning off my mask? Because if I turned on the mask, it means that I am finding out answer from parent, such that I was already visited. If I was already visited, then I cannot visit from my parent again, because there was the question that you have to visit. The question had said that you have to visit every city exactly once. So if you already have visited the city, then again you are visiting from your parents, then it will lead that you are visiting city number I twice, and this will be the this will not the valid path. Okay, so you have to ask your parents. Okay, my parents, you give the answer of how many ways of visiting you with this mask set, with this set. How many ways of visiting you with this set? The number of ways you will give will add to my path also. Like let's say this gives 10 ways, so all those 10 ways all those 10 ways will lead to city number I with this mask. Because if all the 10 ways have all the 10 ways had this mask previously, now when you go from parent to Y, this mask will turn on, and all those 10 ways will lead to set number I with this mask. So for any DP of I comma mask, what you have to do, you have to just ask all your parents DP of parents. You just ask all your parents to give me the answer, such that in that my mask is turned off. And how to turn off your mask, you already know, I think. You just do one left shift I, you have to do just JOR with one left shift I, and you are done. So dp of I comma mask is equal to dp of parents comma mask JOR one left shift I, and this will add up for all the parents. Like you have three parents, then dp of all those parents 1 comma something, dp of 2 comma something, dp of 3 comma something, all those parents will add up to your answer. Okay, so this is our transition. You already know what is the state. So let's look at again something. Your state is dp of I comma mask. This represents number of ways to go from city I to city 1 to city I, such that you visited all the cities that are represented by this mask. What is your transition? Your transition is dp of I comma mask is equal to sum of all the dp of I comma dp of parents comma mask JOR one left shift I. This is your transition and this is sum of parents. Okay, now another thing, what is your base case? Your base case is, let's say you have to find answer for dp of 1 only. You are from city number 1, you have to go from city number 1 to city number 1. So how many way of going from city number 1 to city number 1 there is? And you have also have a mask. So let's say mask is something this, city number 1, you have to find answer from city number 1, and mask is something this. So is this a valid path? Look, like you have to go from city number 1 to city number 1, and you have already visited city number 2, 3 and 4. Is this a valid path? No, this is not a valid path. So let's say 1 you also visit 1. So this is not a valid path, because if you had already visited 2, 3, 4, it means you have started with 1, then had gone to 3, then gone to 4, you have, and then again you come back to 1. So 1 has been visited twice. So if this is the case, then this is not possible to have any answer. But let's say this is the case, dp of I comma, you have not visited anything, you have just visited the 1, you have just visited city number 1. So this is a valid case. It means you have just started your journey, you have not visited anything, you are just at node number 1. So if you are at node number 1, then it's true, this is a valid path. So dp of 1 comma 1 gives you an answer of 1, else all the other masks will give you answer of 0. All the other masks will give you answer of 0. So this is our base case, and let's find the final solution. Let's find the final subproblem. So what will be our final subproblem? So our final subproblem will be dp of n comma 1 left shift n. Reason being, you have to find number of ways to go from city number 1 to city number n. So in the place of I, you have to write n such that all the cities are visited. So in the mask, you have to visit all the cities, all the n cities. So if you have to visit all the n cities, then the mask will be just 1 left shift n. This is 2 raised to power n minus 1. So this will be your final subproblem. And one another thing, to make your code more easier, you can convert everything to zero based indexing. So your base case will also convert to, instead of dp of 1 comma 1, it will convert to dp of 0 comma 1, and instead of dp of 1 comma mask, it will convert to dp of 0 comma mask. And here for the final subproblem, it will go to dp of n minus 1 comma 1 left shift n minus 1. And make sure this will not be dp of 0 comma 0. Like dp of 0 comma 0 is, dp of 0 comma 0 means you have not visited anything, every mask is, every city is 0, but this is not possible. No, have started with city number 1, in our case you have started with city number 0, then you have visited 0. So visiting of 0 is not represented by this mask. Visiting of 0 is also represented by this one represent that you have visited city number 0. So visiting of 0 is also represented by 1. Okay, so that was all from the tutorial orientation point of view. Now let's see the code. So here is the code. Okay, so what am I doing? I've taken n and m as the input. I have made the graph, and one thing I have smartly played here, like instead of putting the values, instead of putting the edge between u and v, what I have done is I have made the edge between v and u. Like I have made the directed edge from v to u. Reason being, by doing this, I already know what are all the parents of u, what are all the parents of any node. Okay, if I had put it in the terms of graph of u comma v, like graph of u dot pushback v, then again I have to calculate all the parents. So all the parents of every node. So you can play smartly here. You just put the age in reverse order. Okay, now where I have made our dp, let's say here is my dp array. Dp of, I have made the size of dp in comma 1 left shift in. Okay, and I have initialized my dp with -1. You can also do the memset stuff, but memset was not working since I have not remembered the header file for memset. So I have made, I have initialized all the dp cells with -1. Then I say, okay, find me the answer of n-1 and 1 left shift n-1. Okay, so here you go. If I equal to 0, it means I am on the city number 0, and if mask is 1, then return 1, and if mask is not 1, mask is anything else, then return 0. This is our base case. This is the another. Here is another base case. If mask and 1 left shift I is equal to 0, what do I mean by this? Mask and 1 left shift I, it means that in our mask, is the ith character set or unset? Is the ith bit set or unset? It means if I am visiting city I, if after visiting I, my ith bit is set or not. If it is not set, it means that you have visited city I and you are saying you have not visited city I. So this is not possible, no? So you will return 0 from here. And this is the dp stuff. Dp of I comma mask not equal to -1, then you will return the dp. Then what will you do? You will find the new mask. What is the new mask? New mask will be, you will ask your parents, just give me your answer. You will ask your parents, just give me your answer with new mask. What is new mask? New mask is just the original mask. Here ith bit is turned off. Ith bit is turned off means you just draw with 1 left shift I. And what is the answer your parents give? You just add to you yourself and take the mod with 29 plus 7. Your mod is 29 plus 7. Okay, you just take the mod with 29 plus 7 and you just return dp of I comma mask equal to answer. So this was all from the coding side also. If any problem still, you can write in the comment section. Okay, thank you.